Let me just see if I can't transfer the file through this meeting, because I have a handouts deal thing that it's supposed to let me use. I just don't think BobCAD's zip file, even if I zip it up, it's not a supported format. So I'll figure it out. Scott, put your email. Just type your email in. No one else should be able to see the questions. I'll just type down your email and I'll send it off to you right when we're done here. Unless you want to follow along now, I can send it off to you right now. It'll just take me a second. So this is the part, and yeah, so like I said, it's got a lot of good examples on it for doing a bunch of different stuff. I also have another part that if we have time, I'm going to go through. This is a curved piece, so it's if your stock was curved, you pretty much treat it like a standard part. It's nothing too crazy. So give me 2 seconds, guys, and I'll have this thing sent over to you if you guys want it. So if there's anyone else that wants the file real fast, I'm going to email it out right now to you, just so I don't forget, because I will 100%, because that's just how I roll. So I got you, Scott, coming in. So right here, give me 2 seconds. Compose an email. Come on. 2 seconds. Come on. Why won't you let me make an email? There we go. All right, cool. I'll have it over to you here in a second, Scott. All right, so I'm going to do the 4-axis mini. Now, when I do these kind of parts, you pretty much have 2 different ways of going about it. You can pick your geometry right off the solid model, or you can take the geometry off, kind of make it 2D, and then do it that way as well. So I like to break it down, but it's whichever one you want to do. Primarily, if it's 4th axis, or if we're doing a 4-axis, I like to do it with a breakdown. I like to break it into separate 2D geometry, just because it makes my life a whole lot easier. Give me 1 second. I'm just attaching this file over here real fast. Recent Wire EDM, and I will send you I zipped a file up. Where did I put it? Oh, no, wrong one. Desktop, web, and 2 seconds. I clicked on the wrong thing, guys. All right, desktop. Go down here. We got our Wire EDM. Right there. All right, Scott, it is on its way to you right now. If anyone else wants it, just let me know. Just throw your email in the questions box, and I'll send it over to you. So, Scott, you should have that here in a minute. It works well if you have dual monitors. If you're only working on one monitor, well, I'm probably on that one monitor. But if you are doing these and you kind of want to follow along just let me know, and I'll get you guys the files you need. And if you have dual monitors, you can throw it up on that second monitor and work it. So when we're doing, let's start out with just a simple 2-axis here. I'm going to do a 2-axis open right along this straight edge here just to get us moving. And so pretty much if you guys have done milling, and I think most of you guys have been in one of these webinars with me in the past. I know at least 4 of you. Gordon and Dave, you guys might be new. I don't recognize the names. Glad you're here. If you've been here before, I apologize. I don't remember every single name. Not even close to it. So I'm going to start off pretty much the same way we start off with any other job that we do. We have our part drawn, and I'm going to start off with the stock so we can start kind of playing around with how we want to cut this part. So I'm just going to right-click on my CAM defaults, say New Job. Now, when we're doing Wire EDM, we have to first of all choose Wire EDM, but then down here you have to pick your machine. So we have a bunch of Mitsubishis, bunch of Fanuc, we got some Charme, some Agi. There's a list through here. Now, I will start by saying not every one of these posts is perfect for your machine. So make sure, whether you test it out right when you get it, if your machine's built into the system, test the post. But if it doesn't work, just work with the tech support guys, work with the post guys. Make sure to give them everything they need, your example files and the GNM codes for the machine, and they should be able to get you a post that's working with no big issues. So I'm going to go here right into the stock wizard. I'm just going to knock this out real fast. If you've done any milling in BobCAD, the stock wizard's pretty well the same, pretty much the same exact one. So for this one, I'm going to go ahead and just make a rectangular piece of stock. And we'll see it's 8 inches by 7.25, 3 inches tall. And then I'm going to go ahead and hit next. Now, when you choose your origin on this part, you should be picking, it's wherever you're going to zero out from. A lot of people go off the table, so it'll be down at the floor level, down at the bottom here. So they might pick a corner like down here. Or if you touch off the top of the part, just pick your normal touch-off point. Wherever you'd normally touch off, if it's dead center, pick dead center on the stock. You might have to pick the bottom point as well. So remember, that right there is the bottom point right on the origin there for us. So whichever one makes sense to you and works on your machine. If your machine has rules, some wire EDMs, they have to go off the table. Just like some routers have to go off the spoil board. You can't go off the top of the part. Same kind of thing. You just got to know what your machine's going to want and maybe do a little testing, find out which one it prefers or which one's easier for you to set up. And then when I'm all done, I'm just going to go ahead and hit OK. Now, I did not pick a workpiece. You really don't have to. When you're only working with one solid, you really don't need to change the workpiece at all. If you have more than one solid, that's definitely where you'd want to start adding your workpieces in, because by setting up a workpiece, even if I have multiple solid models on in my CAD window, if I turn my workpiece on and I launch my simulation, that's the solid that pops up, the one that I selected. So if I had 5 and I only picked one for the workpiece, then that one workpiece is going to be what we have. So right here, we have our stock made. The materials down here, you got tool steel. If I hit edit here, we have our different materials. Now, this is all based on the actual cutting conditions for this material. Not every machine that we have in BobCAD has a database. Some of the database settings are not settings that we put into the system. Some of your machines, you're going to have all your cutting conditions and everything at the machine happening. But for a lot of the ones that do support it, we do have some databases for them. So you can actually go in. If I right click right here on the Wire EDM job, I can go down and say edit cutting conditions. Now, when I get into the cutting conditions, I have a material, a stock thickness, and a wire diameter. I can go in and say, I can set up a new material by adding materials and updating and saving. You can change the stock height. You can change the wire diameter. You can also change your number of skims. And then in that process, whenever you pick a piece of stock that's 3 inches thick with this wire diameter, it's going to pull up all your sizes properly. So not something I usually mess around with. I don't have all the settings that I need to even make a Mark 21, all the new settings that I need for the Mark 21. But, with the help of a manual, or if I could get a hold of one of the guys at Sodic, we could probably put together the database a little bit better, or at least add more materials that I might be cutting to that database. Now, if you right click on the Wire EDM job and you do not have that option, so I believe we'll lose that if I choose like the Mitsubishi here. You'll see there is no edit cutting conditions. And that's because with this machine, either we couldn't get the cutting conditions from the manufacturer. Some of the companies we just couldn't get them from. Mitsubishi looks to be one of those. And the other thing is the database we don't have anything for the database, so there's no database connected to this. Now, if you can figure it out, you can actually go into your CAM defaults or into your Wire EDM current settings. And on the EDM posting tab, there is an option for output cutting conditions right here. And so the cutting conditions will output. There's even a spot somewhere. Where is it? EDM setup. There was a place to pick right here. Sorry. So it's on the machine parameters page. It's right now we are not using cutting conditions with this one. So if we check this button here, we can actually go in and hit select. And inside of our V31 technology folder, you'll actually find some Mitsubishi cutting conditions databases already either set up or at least named. There's even, I believe, a blank one. Yeah, blank database. Now, this does not mean you can go and add all your settings in and BobCAD's going to output them. It is definitely something you can try. You can add the database. You can try adding those things in. But whether the formatting is going to come out right and whether all those settings are right definitely depends on how much work's been done to the post. So if you do build a database, do some testing with it. If you're not getting the numbers and everything you need to output, talk to the posting and tech support guys and see what they say about getting that stuff put in. So done with that. So when I start these jobs, I usually like to break it down into 2D. You got to be careful with this though, because there's a lot going on with these parts. So for this one, for now with the 2-axis, I'm not going to do any sort of pull off. I'm just going to use the part. So I'm just going to right click here on the machine setup number 1. And now you have a choice of a 2-axis inside, outside, or open. The difference between them is the settings that you get. You could pretty much do every part you want with a 2-axis open because it gives you both the punch and the die settings. So you get to choose whether it's a punch or a die. When you're doing a 2-axis inside, you're setting up the die. When you're doing a 2-axis outside, you're setting up the punch. I think I have that right, or you might need to reverse it, but I'm pretty sure. So when you're doing an inside, yeah, you're cutting it out, you're making the die. And so when you're doing an outside, you're cutting the punch for it, something like that. And then the 2-axis open, like I said, that should be able to do just about everything. And, but primarily it's for shapes that aren't closed. So you got your inside and outside, those should always be closed shapes. And then the open, which would be an open shape. And then you have your 4-axis inside, outside, and open. So for this one, I'm going to go ahead and do just this side right here just to get this little cut in here. So I'm just going to go in and say 2-axis open right here. So 2-axis open. And then select my geometry. So all I'm going to pick is the top edge here all the way along. Since it's 2-axis, there's really nothing too special I need to pick. When we start getting into 4th axis, that's where I really start to kind of start playing around with pulling geometry off and doing some of these wackier things that I'll talk about in a minute. So let's go right there. I want it to comp left, so that looks like the direction I'd want to cut in. And so we'll go ahead and hit OK. Next, we can then set up the stock thickness. Is already there from when we set up the stock. The upper and lower guide locations are not something that every machine needs output, but some machines do output the guide locations as opposed to the wire location. So this would be actually where the position above the part is that the guide's sitting. You'll have code come out based on that. Right here, you have process as a punch or a die. So you can see when you process as a punch, you can put a taper on it, but because you're processing a punch, which is an outside cut, you lose the land and taper. So you got punch and die. So I did have it right. So the die should be always when you're doing an inside cut or a 2-axis inside, and then the punch is going to be for your outside cuts. So you could really tell the difference because we have a land and taper. I can't put a land and taper on the outside. So I'm going to process this as it doesn't matter. It's a punch or a die. I make it one cut. I really don't care how it cuts it as long as it's got it. Now right here we have glue stop. I'm going to say no glue stop. I really don't need it to leave or hold the part any way special. So I'm just going to say no glue stop. And then our taper settings. That should be a straight wall. From every time I've ever cut it, it was a straight wall. So I'm going to leave it as none right now. We'll keep it simple. And so it's just going to be a straight cut right along that wall. Right here, we get our machining strategy. So you have strategy 1, 2, or 3. Now, if you have your glue stops on, if you turn that glue stop option on, you will then have another pass in here that's going to be your tab cut. But primarily, all we're doing with this one, I just want to rough it. And I'll just do a single skim pass. So I'm just going to say strategy 1, which gives me a rough cut and a skim cut. And then I'll go ahead and hit next. For the wire, you define the wire primarily by right-clicking on the tool steel over here and then modifying the wire diameter. But I'm all right with a 10 thou wire. The enable starting cutting conditions are cutting conditions specifically for your lead in. So it's when you're first entering into the material. And then you could also set up a rapid feed rate, just so you can override your feed rates and have that rapid feed rate output. Right here's the posting tab. So you have your pretty much just tolerances. This is the same kind of tolerance you're going to come across with just about any feature. 2-axis and lathe also have tolerances in them. They're just inside of the current settings, not the current settings. They're inside the settings, inside file. So if you go to file and then you go down to either the settings part or settings default, they're on that page where you set up the tolerances. The wire EDM and the 3-axis milling give you the ability to set up the tolerance. So you can change the tolerance as you go through the features. So for the most part, I'm going to leave it right there. Right here's work offset. So you have by default, what's this one give me? 59 different work offsets. I'm going to keep it on number 1. And that'd just be your work offset, G54, G55, 56, and so on. And then right here is your posting order. So there's 2 ways to post in BobCAD. You can do individual shape, which means if I'm cutting 10 shapes, it's going to cut 1 at a time. Not only is it going to cut 1 at a time, it's going to do it in the order that I set it up to cut in. So it's going to rough, then skim 1, and then move and do a rough and a skim on another. You could also say go by operation. So by operation is going to go in and rough everything out and then come back and do a skim pass on everything. So that would be how you break it apart based on, you want to get rid of all the rough material and just let the machine finish the part. The by operation is going to work well for that. So I'm going to leave it on individual shape and then go next. Right here's the machine sequencing. This is really only going to be used if you're doing multiple cuts. And we could, on this part, we could do a few different cuts at the same time. But in this case, we really don't need to change anything. It's just how you sort it. One note, you got X direction, you got Y direction, you got closest. They all make sense. Those should just work pretty naturally. The no sorting one is the one that throws most people off because it's no sorting. It's just going to jump randomly. And the reason it jumps randomly most of the time is it all comes down to when you're picking your geometry. If you go in and you just drag a box over all the 2D geometry that you want to cut and then you hit OK, we don't actually take the geometry selection until you release your mouse. So when you drag a box, we don't grab anything until that mouse gets released, in which case then we grab everything that's inside the box. Not in any sort of specific order, though. We just grab everything. So the no sorting goes in the order that you pick the geometry in. So if you drag a box over your part, you're going to get a true no sorting cut. It's going to jump around all over the place. But if you were to go in when you were picking your geometry and you got all say, let's say 2D geometry all over the part and you're just cutting pockets or whatever you want to call them, you could just hold shift, click on every part, every cut that you want to make in the order you want it to run. Then come in and say no sorting. It's going to run in the exact order you selected the geometry in. So that's a good way of kind of getting your order set up specifically. And that's the same kind of rule for milling as well. You'll see it on milling and a bunch of the tool paths, a lot of the 2-axis, that a lot of people always think it's random. It's not random. It's the order it got selected in, but it's random if you drag a box for the geometry. So just below that, we have our start location. This is just saying, if I got my origin down in this corner here, I may want to start with the pocket closest to that. So I could say start at that lower left-hand corner or wherever you want. Right, here's the parameters. So on a rough cut, you only really have one kind of profile. It's a standard profile, especially on an outside or on an open shape. If you pick an inside shape, you get one more option here, which would be a coreless cut. So basically like a pocket with a wire, which we'll look at here in a minute. But right down here, we have our compensation. There's two forms of compensation for your wire EDM, just like there is for your milling. You have system compensation, which is us taking care of the compensation for you. You also have machine compensation. That is going to be the compensation for at your machine. You'll be able to actually comp the wire there. So primarily with wire, you're using one or the other. Either you're using our system compensation and you're letting us offset the wire, in this case 5 thou we need to move over, or you're going to do it at the machine. It's just whichever one you want. Right down here's your stop settings. So if you have a stop point along here where you need it to stop so you can glue up, you can apply stop points and actually tell it when to stop. I don't have any stop points, so it doesn't really matter. The corner types, primarily used for getting rid of excess, cutting a little bit more in the corners, maybe so a part can drop out, giving a little relief on those cuts. So you can leave it on sharp, or you could say, I want to round it. Now, when you say round, this is not rounding the corners of the part. All it's doing is changing how that wire is going to interpolate and kind of roll that corner instead of doing a big 90-degree turn. You could also do loop radiuses, loop lengths, and that'll a lot of times just let you keep your speed up in those corners and come back through. You could do that on external corners as well as internal corners. The internal corners would probably cut a radius in the corner because it has to. If it's cutting an arc for the cut and not making a 90-degree turn, it should leave a rounded corner in there. But it's not intentionally leaving it. It's not even asking what size radius. That's kind of how you know it's not doing what you might immediately think it's going to do. When we say round, if we were truly trying to round all the corners and make radiuses, it would ask what size radius we want. This is just changing how the wire, or if the milling has this as well, it's how the tool goes around that corner. So I'm going to leave them on sharp and then hit next. Right here's the leads. So your start hole diameters are more important when you're doing a coreless kind of cut. A coreless cut is kind of like a pocket. We're going to go in, instead of just making one pass, we're going to start from the inside and kind of work our way to the outside. So taking small passes to get all the way out there. Well, with the start hole having a diameter, you're able to come in and tell BobCAD where the hole is, so we could center up with the hole, and also what size it is, so we know what area we don't have to worry about. If you put a 1/2-inch hole down the center of your part, we don't have to cut the 1/2-inch area that was drilled out. We're going to start a 1/4 inch, off that radius, off the center there. We're going to move it a 1/4 inch over and then start cutting. So we're going to ignore whatever diameter hole you tell us you put in here, especially when we're doing the coreless cuts. Thread wire vertical, not too much there. It's just going to thread the wire vertically. And then your leads right here. So you have perpendicular, you got circular, you got a perpendicular blend, you got parallel, which is the ones we're going to be using. And then we have a select point, which is one of my favorites because it allows us to go in and actually pick a point where we want it to start. So if you put a point in the middle of a hole where you're going to feed the wire, you can actually go pick that point. And then in version 31, I don't think it was in version 30. I could be wrong. Don't quote me on it fully. But the perpendicular to closest, what this is going to do is after you pick the point, if you check this button, it's going to make a perpendicular move from that point to the closest wall, and that's where it's going to start the toolpath from. That's how it determines where to set that cut up. You can also move the start point around, but if you have this button checked, it's going to automatically go to the closest. So I'm going to go here and just say, let's do a parallel here, because I actually want it to start off the part, come in, make this cut, and leave. So right here for parallel, I don't know how much extra I need. I don't know what size this fillet is, but I'm going to go ahead and give it a 1/4 inch extra. Hopefully that's enough. If we need to, we can always add in a little bit more. But make sure you don't have to, but you can use your leads to take care of some of the cutting for you, especially these parallel leads. All you have to do is overextend them and don't let the wire come in a little earlier and exit a little later, and you've just cut the entire part, even though all we've selected was this chain here and not that radius in the back. So I'm going to go ahead and just say, I think a 1/4 inch should be long enough. We'll find out. But there's a button here that you can handle more things with. So in the bottom left-hand corner of this box, there's a button called Apply to All Operations. It's a button that's there all the time. A lot of people never even notice this button. If you're one of those guys, leave me a comment because, no, a lot of guys don't ever see this button. And so what this lets you do is lets you copy your pages so you don't have to do them over and over again. Real handy when you're doing a whole bunch of lead-in pages and corner types and really anything that you can copy from one cut to the next. If you look in that bottom left-hand corner and there's that button for Apply to All Operations, you can take anything on this page, apply it to all operations, and then any other leads page that's in this tree over on the left is going to copy and match those leads. So you do have to make sure it works for every single cut because a parallel lead-in might not work when you're going and doing your tab cut. And if you did do this with a tab cut set up in here, you'd have a parallel tab. So you may have to play around with some of the settings there. Right here we go next. Right here's the cutting conditions. So I do not mess with the cutting conditions until I'm completely on the last page of the toolpath. The reason being, when I go in here, even if I know them, because I can go in and edit my table and start entering all my information, whenever you choose a rough and a skim, BobCAD only puts one skim pass in. So I'm going to go ahead and hit OK and then hit Next. On this page here, I can actually tell BobCAD how many skim passes I want. So I usually wait until I get to the final cutting conditions page of the entire toolpath before I even start setting up the parts. Because if I do multiple skim passes, in this case, I'm only doing one, but in a minute, we'll do 3 skim passes. If I'm doing more than one, I want to wait until I get past this page so that I know that I have 3 skim passes. So I'm going to leave it at 1 for now. Standard profiles is going to go in, make its cut. You could flip the pass direction. So if the first one went, we'll say clockwise around the part and made the cut, the second one would go counterclockwise and it just comp to the other side. You can also say with your skim passes, you want to reverse them as they cut. So skims in the same direction, keeps everything moving the same direction. Reverse skims is going to cut one, let's say clockwise. The second one after that would be counterclockwise, and then another clockwise, however many skim passes we set up. So I'll just say keep skims in the same direction. System compensation's off, machine compensation on, and then I'll hit Next. Right here's our corner types. I'm not going to change much on there. Next, right here's the leads. So you can see this leads page matches the earlier leads page, even though normally the default would pop up with circular or perpendicular. Now we have the parallel settings because we used the Apply to All Operations button. So right there we have our length. Next, we have our cutting conditions. Now, the reason I wait until I get to this point again is because if I go into the edit table now, after I'd normally have defined how many skim passes I'd have, if I put 3 in here, I'd have 3 skim passes now. Earlier, I'd only see the 1 because at that point, I haven't defined the amount of skim passes I want. So I'll go ahead and you can go in, you set up your power settings. This is all settings specifically to your machine. You can tell it the offset, feed rate, the speed, the tension, and any comments you might have for that area. Then when we're done, we hit OK. When I'm really done, I can go down here and hit compute. And so it's tough to see, especially because we don't have any compensation turned on for BobCAD. We're just using the ones that the machine compensation. So what ends up happening, if I go over here and I add a new layer, I'm just going to call this now 2D Geo. Is my caps lock on? Yeah. Geo. And so if I turn the CAD layer off right now, you can see there's the cut right there. It just lines up perfectly with the edge. And I think we'll be good with the leads. They're really close to the top of that. Yeah, we'll go bigger. Let's just go in. Let's edit this. Go to the leads page. And this is the best part. I make the change here. So I'll say a 1/2 inch. Apply to all operations. And that copies those settings over to here. So now I have both the same leads pages. So I can compute again. There we go. Now we should be a little bit further off that part. So now we have that one. So that's a 2-axis open. Like I said, that one's a big time use. Right there we have that one, and then down here, let's see, we got this 2-axis right here with a land and taper. So you got a small land there and a taper. I'm not sure what the land is. Let's go find out. Let's go set this thing up. So when I do these kind of parts, you can pick, because you're doing a 2-axis inside, we can go in and just say, I want to select the geometry, and I'm just going to pick the whole outside of this. Now, one trick to getting this, and this works anytime you're selecting geometry, like we're doing here, or boundaries. And that's a big one because you can use this for doing 3-axis milling with boundaries. But what you do is you hover over the edge. Don't click on it. You just hover over it and make it light up that pink or whatever color you use for your highlighting color. And then right-click on it, and you'll get 2 options, Constant Z and Loop Selection. In this case, because the entire shape I'm thinking is on the same Z level, I'm going to say Constant Z. And if everything works, I'd like to see it. There it goes. Grab the entire chain around the top of that. And because it's all on the same Z level, it should grab the entire chain. So from here, I can go in and say, right here, we can set up a start point. So we can actually go in and we can say start at the start of the chain, start at the longest entity, or start in the middle of the longest entity. We could also come in and click on the chain here and actually pick by clicking where we actually want this thing to start. So we can click where we want and also look at our direction here so we know which direction we should be compensating in. I like to do it just because it's easier to figure out now what comp I may be using, even though a 2-axis inside will figure it out and it will change it. If we flip the direction of this chain, BobCAD will automatically flip the compensation that's coming out at the machine. So if this is going to give us a G41, if we flipped it so we'd get a G42, BobCAD would automatically make that switch for us. So we'll go ahead and hit OK, go next. Now, I don't know what the full land and taper is. I think the land height, I'm just going to guess and say it's 1/8 of an inch. Taper angle, we'll say 3 degrees. I didn't read it. I didn't really mess with this too much. But one thing you could do is program this as a 4th axis if you wanted to. You could pick the top shape and pretty much do the straight cut through, and then you just do the top shape. So the first one would be a 2-axis, straight feature. Just goes in, cuts this basic shape in. The whole wall would be straight all the way down. Then you can come in and do a land, or kind of the taper, and leave that land. So you'd pick the top shape and the bottom shape and let it cut in. You'd actually not want to pick the top. You'd have to pick this edge here so it knows to kind of taper away from there so you're not screwing everything up. So I'm going to leave it for the land and taper. No glue stops. I don't need that stuff right now. We got the land on top. If you wanted the land on the bottom, you would click that button there. And then how this actually displays is normally what you'll see when we compute this is you'll see just a straight cut, but it doesn't show you the full straight cut all the way down. So you see just the top half where you get the straight, and then you'll get a taper, but it doesn't show you the wire kind of taper. So if you go in and you say taper display extend, this is going to switch it so that whenever we do a land and taper, the land that we see, so this area here, if we leave the taper display on and this one off, what we'd see is the taper is going to have a wire that goes, you'll see the line for it go all the way down, and then another line that goes in and cuts for the angled sides. So it's just a difference in how it displays. It doesn't change anything about the tool path. It's just a lot of people prefer one way over the other. So play around with those settings, either uncheck the use job settings and run the taper display extend, and just kind of see which one you like a little bit more. I'm going to do it the standard way. This is the way it should show up with the system. Now, the taper angle can be negative. I mean, really, when you're talking about the tapers and stuff, you have a negative to the left and a positive to the right. So you can play around with those settings as well. For this one, same strategy. I'm going to do a rough and a skim. This time I'm going to do a few different skim passes, though. So we'll go next. Starting cutting conditions, that whole page. I'm not making any changes there. The thing with most of these tool paths, especially like the lathe, the wire, the ones that don't have, like the milling has so many different tool paths with so many different settings. It's kind of tough. With a lot of these, it's a lot of very repetitious kind of things that we're doing. So we got to go in here. We choose our standard profile, turn our machine compensation on. You'll see we don't even get a choice this time. It's a G40, whether it's a G41 or a G42, because it knows to do the machine compensation based on the direction that we're cutting in. So there we have it. Right here's our taper settings. If we want to apply taper on the rough pass, you'd say apply taper, which is what I'm going to do. If you wanted to leave it for the finish pass, you can uncheck the apply taper button here. Let the finish pass take care of it. Next, we then have the corner types again. No changes. Right here we got our leads. So this one we can go and set up. I don't have a point, so I'm just going to go perpendicular. Yeah, I should be fine with that. We'll go perpendicular off that point that I selected. And if we see any sort of collisions, we could always move our start points around. But that's not too important to me. Really, what I like to do, though, is put a point, especially on the inside of this part. I have to have a hole drilled in here somewhere to feed through for the most part. I mean, yeah, usually. And so I'd usually put a hole in there just so I can pick the center of it and say, feed the wire right down the center of this hole. And if that's the case, you're going to do a select point right here, and you'll be able to pick it up. So next. All right, cutting conditions. You got your 2-axis. This is, again, don't worry about the cutting conditions until you get to the last one, because right now, if we look, there's only 2 passes happening. When I go ahead and hit next, though, I'm actually going to do 3 skim passes on this one, not tapering this time. No corner types, no leads, no changes here. And then right here, now when I go into the edit table, we'll see I have the rough and then all 3 skims. That's the whole reason I wait until the end before I even start messing with my cutting conditions, because if I start setting them up at the beginning, well, I don't know if I have all the passes I plan on using. You could set it up, but like I said, if you do it at the end, it's retroactively working. If I go in and change the power settings here, even if I don't change them under this cutting conditions list, it's changing the rough and it's changing all these skim passes for me. So when we're done, we can hit compute. And so there's our little lead there, and we just got a little cutout. So hopefully that's gonna, it's gonna plunge right through the part because I don't actually have a hole on there, but there we go. So that's your 2-axis open. You got a 2-axis kind of inside like that. Now I just want to talk a little bit about the 4-axis because there's a lot more that factors into this, and I like to break it apart. So what I'm going to do is I'm going to extract some edges off this part. Actually, I'm going to extract the edges off every bit of this part. So let me go ahead and blank out all these tool paths. I'm going to go up to the Create 2D tab, and I'm going to use Extract Edges. Now, I have my check mark on my new layer, and there's nothing else on that layer because I haven't pulled any geometry off. I haven't drawn anything. So 2D Geo is blank, check marks on it. So now I go to Extract Edges from Solids in this case. So I'm going to go in, I'm going to pick this whole solid, and then I'm going to right-click and hit OK. Now, we're going to get a lot of geometry on here, and it's real messy. But if we just kick it to a top view, we shouldn't have too hard of a time just going in and deleting the things I don't want. So I'm just going to delete that. I'm going to get, almost deleted too much there. Delete that. I'm going to delete all of this over here and then zoom in and try and grab all this. So all I really want is this 4-axis kind of blisk that we have here. So I'm going to delete every bit of geometry we have. Let's see if there's any more vertical ones standing. No, that looks good. So I have all of the geometry for that blisk shape. that kind of geary shape, but it's got a curve. If you had to draw this, you'd pretty well draw it a gear for the top, a gear for the bottom, and then twist them. So you'd rotate one, and then basically, like you see here, draw a connection line between all common corners if you can. It's a messy process, but it does work. So now there's a lot of these lines right through the center of this part that are definitely going to screw up my geometry selection. So what I want to do is I want to take those lines and move them onto another layer. Now those lines, if you want to give them a name, are the sync lines. So sync lines. So with the sync lines, I'm able to go in and actually tell BobCAD that at certain positions, so each one of these lines, like this one here, when the top guide gets to here, the bottom guide should be down here. So we're using this to kind of cut that whole thing. So I'm going to go to a front view just by hitting Control-2 on the keyboard. And then I got my select tool already. And then I'm just going to drag a box right through the middle of this. Now, I'm not going up and touching the top. I'm not touching the bottom. I'm going right through the middle, small enough that all I'm touching is the lines. Then I'm going to right-click, Modify Attributes, Layer, and then Layer 2. I didn't click out of the box there. You'll see it update in a second. So now if I go in and I turn off the sync lines, it gets rid of those two. And so the only other thing I want to check on is just make sure these two parts are good. Make sure they're clean. So I'm going to cancel out, grab my select tool, and then just hold shift on my keyboard and click on these shapes. What I'm looking for here is that they light up 100% around. If there was a stop, if it went around and then stopped where the blue and the red, my part's blue, so that's what I get. Where the red and the blue meet, that's where you want to zoom in and start looking. So if I zoomed in and it stopped over here and my chain was red and then it went back to blue, you'd zoom in on the area where you had the red chain meet the blue. And a lot of times you'll either see that you have an overhang, a gap in the geometry. Sometimes it happens with solid models. When you pull it off, a solid model might look really clean when it's made, but as soon as you start pulling geometry like lines off, you might see that it doesn't mate properly and it just doesn't clean up. So you'll be able to clean it up. The other option, the other problem you could have with it would be any duplicates. I've done it thousands of times where I go to extract edges and I end up extracting edges twice. It's just something that I've just done it a bunch of times. So if you accidentally do that, you go up to Utilities, evaluates for dimensioning. You go to Clean Up and Optimize. Now, Clean Up and Optimize reduces the number of entities within the drawing by joining curved segments and this is the big part, getting rid of any duplicate geometry. I taught a class for a few years, and I for the longest time, I didn't know that the Clean Up Optimize both cleaned up the geometry, so it rejoined my lines together. If I had a straight line that was broken into 5 segments, it rebuilds that, but it also gets rid of duplicates. So the erase doubles, you're only going to use if you don't want to rebuild your geometry. So if you're using the Clean Up Optimize, you're rebuilding geometry and getting rid of duplicates. But there's certain scenarios when if I have 2 lines crisscrossing and there's duplicates on them, I don't want them to be one individual line crisscrossing another. I might want it broken into 4 separate lines. So if you use Clean Up Optimize, it's going to rejoin that geometry. If you just erase doubles, it's just getting rid of the doubles. So there is our top shape and our bottom shape, and then all the lines in the middle of it are the sync lines. So we can go in, and we're not going to mess with the sync lines for now. We're going to play around with this, but we're going to go down. I'm going to do a 4-axis inside. And they made it pretty easy to set this up. You can say, I want to select my upper profile. So I'm going to come in. And I kind of want to pick close to the same area. So I want to go here and here when I pick the geometry. So I'm just going to hold shift. And I'm specifically clicking on a specific point of this line. So if this is the midpoint, I'm going before the midpoint. And then I hold shift and click. And the reason I did that was because when you click, depending on which side of the line you're on, when you hold shift and click, it'll actually send the chain a specific direction. So if I hold shift and click right here, it sends the chain around the part this way. So it'd go all the way around and then eventually come back here. And if everything's good and clean, it should end up with a red line back where we started. So there's the upper geometry. Now I'm going to go ahead and do the lower geometry. And same spot, just hold shift and click. I want to be as close as possible when I'm picking my geometry, because a lot of times there's the start point. It doesn't even pick the start point. I was shooting for it, but it didn't do what I wanted it to. So I'm just going to move the start point over there anyway. And then right here, I'm going to go to the lower chain profile right here and just do the same thing. I want them both sitting right in the middle. So we should now have both start points. We want them close to each other. Otherwise, if you put two start points on opposite sides of the part, it will put those start points on the opposite side of the part. I actually just did a part a few weeks ago with a guy that in the middle of the part, basically it was two funnels, one on top of the other, and he had to figure out a way to cut it. The only way to cut it was to perfectly center the wire right in the middle and then set one start point on this side and another start point on this side. He was just cutting circles, but pretty much this side went around and cut while this side went around and cut the opposite. So if you drew an angle between, from here over to there and then spun that angle around, he ended up with a really clean part. I didn't think it was going to work, but it came out pretty good. So we'll go ahead and hit OK. Now, for now, I'm going to leave the sync lines off of it. We have every sync line we need, and that should be good enough for us. But I'm going to leave the sync lines off for now because we have some syncing options right here. Now, these are not always going to be the best options to use. Sometimes drawing your sync lines is a much more consistent and just a better way to go all around. But we'll go by entity first. We'll see what kind of cut we get. So syncing by entity means it's going to look at the total number of entities and kind of determine where we should be syncing based on the amount of entities. In theory, this should work really great because these two parts should have the same number of entities, but it's not usually the option I use. So we'll go with by entity for now. So we'll go next. We'll do our strategy, just a rough and a skim pass, nothing crazy here. Next, not much that you're going to be changing. The biggest part with Wire EDM isn't even really learning, how to use BobCAD too much. It's more of setting it up. I don't know what's the best way to put it. It's more of getting your machine and everything all set up. You're doing the tool pass is actually the easy part for a lot of most situations. It's really not too bad. You pick the geometry, you cut it. It's getting all the settings that you need to make everything work properly. That's the difficult part. I didn't put a point on this one. I really should have. I'll come back and add a point in a minute, but I'll use the perpendicular for now. The benefit of having a point, especially on a fourth axis, is for a fact you're gonna feed that wire to the same point, and then the wire is gonna move to its position and put itself in the correct position for us. So I like to use a start point usually for my leads, but no big deal here. So then we get the parameters. So I'm, again, only doing one skim pass, machine comps on, and no stop points even selected. Leads, perpendicular, again, that's fine. And when we're all done, we can hit compute. Well, normally you edit your table, set it up, but we're going to go ahead and hit compute. There is the geometry, and it looks pretty clean. It looks like I have some where you could see it's definitely crisscrossing in a way I wouldn't want it to. Right over here is a good example of that, or pretty much every one of these corners. Our sync is going from the top of this over to this over here, which really that sync should line up pretty close, actually. That's not bad. That's not a bad sync. Where should that be lined up with? This sync, yeah, I don't know. We'll look at our sync lines. The thing about sync lines and kind of setting up the sync lines, if you have a solid model and you've done your extrusion or you've done it however you created it, a lot of times the geometry that connects the top and the bottom together can be used as sync lines, just like this geometry that I pulled off. So you can see this is kind of the good sync lines that I'd want to use. You can see right here, this is what, by proportion, I think. No, this is by entity. Not really the way we want. And it's mostly because the parts are just turned a little bit. Same number of entities, but because that part's got that slight turn to it, got that slight twist in it, that by entity is probably getting thrown off. So let's try by proportion. We'll go ahead and hit compute. I think it's computing. I don't know what's going on. Oh, there we go. Okay, it's done now. So that one looks a lot closer, a lot closer, really. Pretty good. We can see some of these areas. No, they look pretty decent, man. They came out pretty good. By proportion, I could see some areas that I might have some better sync lines on. But all in all, not bad. The best way to really see it, you'd have to run the simulation on it and see how it falls out and see if it cuts the right part. But, you know, even with that, I shouldn't have sync lines in the middle of this straight line too much. It should be kind of angled over. We'll try it with the last one here, which is by closest. So by closest, I'll hit compute. We'll give it a second. Not sure why it's doing this whole thing, but it's just it's computing the toolpath, but it's not giving me a box to compute the toolpath. Usually it's a pretty instantaneous, quick change. So we'll see what's happening here. Well, hopefully this makes it through it. We'll find out. Right there. All right. Oh no. We're losing it, guys. I don't know what I did wrong. I don't think I did anything wrong. I think it's just BobCAD being weird. I should probably close SolidWorks too. Hold on. Get rid of this. This. Well, if that doesn't tell you, don't run 50 different programs at the same time. That was probably more my fault than BobCAD. Probably BobCAD too, but I'm not going to try and lie and say it wasn't BobCAD. Definitely probably had something to do with it. But yeah, I'm overloading my computer right now anyway. All right, let me rebuild this part. Should only take me about, I don't know, 15 seconds. It's not bad. But yeah, definitely something. That's a big problem I have myself is I don't actively look at what's going on my computer. So I've got 15 programs running all at the same time. All right, we'll open this up. We'll go in. Let me make my stock real quick. New job, Wire EDM, stock wizard. Next. Whoops, didn't even mean to do that. Stock wizard, rectangular. I'm just going to hit OK. The origin's down at the bottom. I'm not really too worried about it. So blank that out. All right, so right here, add new layer, 2D Geo. And we'll re-pull this geometry. So utilities, extract edges. I'll create 2D, extract edges from solid, pick the solid, OK it. Turn it off, and then again, just like I did before, I'm just going to go in and delete anything that I can get rid of. That was a good one. That was a good swipe. Oh, too good. Too good on that one. All right, there we go. Delete that. Delete all that. And then you got to be careful. There might be some lines that you just miss because they're standing vertically, and so you won't get them. You got to make sure to delete those ones. So make sure you rotate around and look at them afterwards. Now I'm going to do my sync lines. Front view, drag a box. Again, don't touch the top or the bottom. Modify attributes, layer, sync lines, or what it didn't rename yet. And then right here, I'm going to start my 4-axis inside, upper profile. Right here. Lower profile right there. This time, I'm going to choose the sync lines. And that's just because they're easy to pick. I'll go to a front view. I'll drag a box over those and then pick my start points real fast. So start point for these guys, let's turn this back off, is going to be, I like to go to a top view and then just skew it ever so slightly. We'll have it start on these two here. So I'm going to say chain 1 starts there, chain 2 starts down there, or upper chain, lower chain, and then I'm going to just hit OK down here. So we'll scroll down, hit OK. And now I should have everything picked. So this time, these sync options, now that I have entities selected for the sync, we're not going to be running those. So I'm going to turn the glue stop off for now, and I'm just going to hit compute and let it give me some toolpath. So hopefully it compute. There we go. That looks better. So pretty much what it does now is it uses all those exact lines that I created or that I pulled from the model, which is pretty well what I would have used to create the model in the first place, because this is all custom surfacing anyway. Unless you made it and then subtracted it. But I'm going to go ahead and launch the simulation. So I have it lined up the way I want it. Origin looks good. A really big part of this is getting your start points right, because BobCAD will create this toolpath, and a lot of times it even looks fine until you actually see how it's cutting. So let's go here. I'm going to turn on my machine housing. So this is a little thing. If you go to the visibility tab and your machine housing is turned off. If you turn it on, it doesn't actually show you the housing for the entire machine. It gives you your guides. So it's a little easier to kind of find out what's happening here. So I didn't set up a point or even a start point, but you'll see it's just going to go in and make its cut. So I'm going to do this two different ways. We're going to cut it once like this. Now over here, we have the measure tab. If you don't have the measure tab turned on, you can get to it just by going up to view and just turning your measure tab back on if you might have turned it off. So it's all done now. I'm going to turn off that machine housing again. Try that again. Hide that all the way. So I'm going to turn off that machine housing. So we have the inside part here and the outside part here. What's weird, and it's kind of in a weird spot, I get it. But with the measure tab, you can actually go in and remove chips. So you have remove chips, only keep one part. You have remove chips, select chips. So I'm going to use the remove chips, select chips. And I'm going to click on the main part of this solid here, this big old block here, because I want to get rid of that. Oh, we didn't break all the way through somewhere. So normally it would go in and get rid of just the part that I want to keep. Let me restart this, and we're going to look through here and find out if there's an area that didn't get cut. So let me fast forward through it again. And I'm going to go try and look at it from the top and the bottom. Hopefully it should be cutting all the way through. Son of a gun, I hit the wrong button to rotate. Just so you guys know, rotating in your simulation is done with your left click, not your middle mouse wheel like you do everywhere else ever. Right here. So rotate. Did I make my stock too thick or what's going on? There's probably a small connection. There it is. Some weird cut that happened down on the bottom. So we definitely got to go figure out why this didn't sync up nicely here. But that's the reason I'm unable to get it to break apart. It's because of there's somewhere in here this isn't cut fully and it's touching. So it thinks when I say remove chips, keep one part or select chips, it's all one because it's touching. So we'll have to look at the start point on this and see what we got going on. So did I click it? There we go. Let's look over here and see. A big part of it's probably the fact that the wire came in straight. Yeah, there it is. So you can see there's a weird, it's our lead. So I'm going to go in. I'm going to put a point on the middle of this part. I ain't got to be perfect. I'm just going to go create 2D point. I'm going to slap that thing right. That's pretty close to the middle, I think. That's good enough. So I'm going to pick that and say, you know what? There's where the hole is. So I'm just going to edit this, go to my leads page, say select point, and then go and pick my point. So I pick the point right there, and then I go ahead and hit OK. And then I say apply that to all operations, and then we'll go ahead and hit compute. And so it should be feeding pretty much from that. So it should be synced up there and then move over to this position. So this should hopefully clean up that weird connection that we got going on and hopefully get rid of the weird movement that we had in the corner there. We can check it out inside the simulation one last time. Here we go. All right, if you guys have any questions, start putting them in now. If you have any questions, specifics, anything you want to see or anything like that, I'm going to try and get to them here in a second. So we're pretty much done here. So that's going to go through, do its cut. Looks like a weird snake with that preview, the way I got it. So hopefully that cut all the way through. I'm going to flip the part over. We're going to look at it. Oh, it didn't. It left that small little tab there. Why, though? Do I got two different start points on here? I may. Whatever. I normally probably have to do a tab cut on this to slice it off or another pass to get it cleaned up. So I can't get rid of the part right now. But yeah, setting up your geometry, top shape, bottom shape, sync lines, and usually the sync lines, for the most part, can be pulled off of the actual model. I have one other model I'll pull up, which is this Blisk right here. A much bigger one, but same kind of concept, except this one would be the it's just got more cuts to it. Larry's saying the lower start should maybe be one tooth over. Yeah, I probably do have to change the start point back on this one. I'm thinking maybe if it's synced up here, we'd want it to possibly sync over to there. Let's try it. Lower geometry. We're going to modify this start point. And I'll go ahead and pick this side over here. Maybe we go to the inside of these. I don't know. That seems like it might be better. I wonder how that syncs. Let's see. I'll go ahead and hit OK. I'll move it to the other tooth if this isn't even close. But that might sync it a little bit better because that's a little straighter than what it has to normally start with. So we'll say compute all toolpath. I don't know why it doesn't give me a loading on there. What is this? Did I not apply to every feature and I still got some weird... That's not what I picked. Select point. Pick points. You got the point picked. There it is. Apply to all operations. Leads. Dived. I may have missed it. I don't know. I want to see this line disappear, though. I don't know why that's even there still. There we go. So now, is that too tight of a weird meetup in the middle of that? Is that going to give me a decent... it might give me a decent cut. Let's give it one more shot. There we go. And I'll just fast forward through the whole thing. Hey, that looks a lot better. Now, as long as that's disconnected, my worry is that it might not... Oh, got the angle there. Well, let's find out if it's disconnected or if I got some weird little geometry inside of there. Whoops, wrong way. Let's fit everything there. So we'll try it this time. We'll say measure tab. Go down. I'm going to say remove chips, select chips. So I'm saying let's get rid of this big body here. Yeah, it's still connected somewhere. I don't know if it's my... I probably just have a bad cut happening, but normally it would go in, and this should cut all the way around. I might need an overlap amount. I might need to move the bottom or the top to a different location like Larry just suggested. But the top looks good. I just don't know where it's supposed to be breaking through. I don't know why it wouldn't be. Oh, it's right there. I might need to just do an overlap on the lead out, but we're really out of time. I'll play around with this, and at some point I'm going to do kind of a compilation of all my mistakes during these and correct them, hopefully. Last week I was trying to do the translate, and it was giving me a hard time. And then after I got off this thing, the translate worked completely fine. I never had an issue with it the past week. So